My student ID is 230100084, and this is my smart environment monitoring system. And here is the project overview. This project implements a smart environment monitoring system on a Raspberry Pi using a real sensor head, uh, a local SQLite database, a Frank backend, and a browser-based data dashboard. And the system collects temperature, humidity, and pressure data from the sensor head, store it at this reading locally, and evaluate the living warming threshold, and provide a responsive web interface, perform the temperature trend analyze, and predict the possible threshold crossing, and shows the worrying state both on the dashboard and the sensor head LED matrix. And this implement was designed to match the seismic requirement across the UI while staying the elasticity for the Raspberry development. And the final system embraces the five quality. And the first is the continuous sensing from the real hardware and local persisting storage, live browser-based monitoring, and configurable warning and prediction. The practical security and reliable control. And on the left of the screen is the dashboard for the smart environment monitoring system. And here are the architecture summaries. And on the right of the screen below is the basic coding architecture. And for the data collection and storage, the system collects environment data using the system head and store it in the local database. In this project, this environment values are temperature, humidity, and pressure. And the real sensor head hardware sorted the data into the local SQLite database on the Raspberry Pi. And data collection began on sensor layer, the sensor manager in the app sensor.py. And initialize the physical sensor head and read the current sensor value. Each reading is normalized into the structured object with the record at temperature, humidity, pressure, and sensor source. And the time step is recording to the UTC ISO format so that value can be stored and rendered constantly. The sampling frequency is defined constantly in the config, and the current value is the 0.5. This means the system sampling the environment every 0.5 seconds, which is equal to 2 hertz. Actual conscious collection is performed by the backend service in the service part, and this collectors read repeatedly read the hardware, evaluate the threshold, store and result, and then wait for the next interview. And this is important because decouples the sensor pulling from the web request. Here are the real sensor reading core code. And the SQLite index gamma is defined to in the DB pi, and the system is util table reading and setting. The reading table story every collect sensor sampling together with the warning text, and that will active that moment. And the setting table stores the currency active threshold value, and so that the user change can persist across the request and across the restart. Here are the basic data script. And here are the controls collection loop. Here are the how to insert into the SQLite. And this page is this code to provide the everything. This page is to show that how the database become. And for protecting our dashboard, we implement the responsibility web interface with the live data. And the front end is built with the server running HTML plus plain JavaScript and CSS. This approach to keep the stack lightweight and suitable for Raspberry Pi, while still supporting the dynamic updates. And this dashboard page is defined to the template indexed HTML. It includes the following section. Here, the following section. And styling in the CSS using the responsive layout rules so the page remains usable across the wide and narrow screen. Here are the white pie, and here are the dynamic setting update. Here how the lab updates via the server send event. Here are the warning system with the default and custom thresholds. Here are the LED warning display and the runtime threshold update. For the security risk, uh, we implement the login system, and you can see my left screen. I can click the logout, so I can log out the system and use the admin 123 to log into the system. So here how the interface to become how the input the validation, rating limit, and the security headers, and the limited network explores. And for the data analyze and trend-based predictor, we have the spike detection to detect it, and it's the tempo trend detection. And on the left screen, here is the temperature here. You can see the spike detection and trend detection. Best trend section, how to calculate the score. And this trend is a trend-based threshold prediction. Once the sustained trend is detected, the system predicts when temperature may cross the relevant threshold. And if the trend upward is predict when the temperature may rise above the maximum. If the trend is downward, is predict when the temperature may fall below the minimum. And here are the basics, system reliable error handling code. And centralized configuration. We implement the config pi and to change all the data from here. You can see the sibling interval seconds and the default history limit, max history limit. And you can see the left panel. Here is the 1,000 sampling. If you are changing 1,000 to 10,000, if you will show more data. And how to set up the configuration. First, we power up the Raspberry Pi, attach the SSH hat to the GPIO, and power on the Raspberry Pi to ensure that the SSH hat is physically recognized by the operating system. And we CD to the IoT at 4 and use the Python VEV to source into this interface and install all the requirements, and finally run PI and open the browser at the 8000 port. And the login username is admin and password is admin123. You can change the username and password in the configuration. Here are the conclusion, and this project satisfies the assignment requirements through a complete Raspberry monitoring workflow built around the real SSH, local secret persistence, a responsive AuthNet dashboard, configuration warning thread, and temperature trend analyze, and thread crossing prediction, and practical security and reliable control. This implement does not only display raw sensor value, it also stores them, interpret them, and protect access to them, and report failure clearly. That combination makes the system suitable both as a technical assignment submission and as a reliability prototype for the local environment monitoring. Hi, and now you can see I have connected to my Raspberry Pi, and the system is running. And the light is show green. You can see that the temperature is 36.6, and the humidity is the 31.8, and the pressure is 1030. So here is the temperature trending over time, and his green. Here is the stable state, and it's green. So I manually changed that the temperature mag to the 20, and here you can see as the light is turned green, you can see that the warning shows temperature 36 to outside the 0 to 20. So the warning system is worked, and you can see the nose if the temperature is stable and the zero shot crossing is time and stable. You can see the confidence, the average step in the system, and the setting is easy to adjust the OD config. And here is the optional notes, and that's all presentation for the project.